Radiation refers to the transmission of energy in the form of electromagnetic waves or atomic particles through space. There are two main types of radiation: particle radiation and electromagnetic radiation. Particle radiation consists of particles that have mass and may be positively charged, such as alpha particles, or negatively charged, such as beta particles. These particles can be emitted from radioactive materials and can travel relatively short distances through air or other materials. Electromagnetic radiation, on the other hand, consists of waves of energy that do not have mass and travel at the speed of light. This type of radiation includes visible light, X-rays, gamma rays, and radio waves. Electromagnetic radiation can travel through air and many other materials and can be produced naturally or artificially. Gamma radiation, beta radiation, neutron radiation, and alpha radiation are all types of particle radiation. Gamma radiation consists of high-energy electromagnetic waves emitted from the nucleus of an atom. It has no mass or charge and can travel long distances through air and other materials. Beta radiation consists of fast-moving electrons or positrons emitted from the nucleus of an atom during radioactive decay. Beta particles have a negative charge and can travel short distances through air and other materials. Neutron radiation consists of particles called neutrons that are emitted from the nucleus of an atom during radioactive decay. Neutrons have no charge but have mass and can interact with other nuclei, causing further radiation to be produced. Alpha radiation consists of particles called alpha particles, which are composed of 2 protons and 2 neutrons and are emitted from the nucleus of an atom during radioactive decay. Alpha particles have a positive charge and are relatively heavy, meaning they can travel only short distances through air and other materials before losing their energy. The electromagnetic spectrum includes all types of electromagnetic radiation, including those that can penetrate the Earth's atmosphere. This spectrum includes various types of radiation, such as radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. The frequency and wavelength of electromagnetic radiation determine its energy level. Radiation with higher frequencies and shorter wavelengths has more energy than radiation with lower frequencies and longer wavelengths. The temperature of a body also determines the type of electromagnetic radiation it emits. As the temperature of a body increases, it emits more radiation with higher frequencies and shorter wavelengths. Some forms of electromagnetic radiation, such as ultraviolet radiation and X-rays, can be harmful to humans. Exposure to high levels of these forms of radiation can cause damage to cells and increase the risk of cancer. Infrared radiation and visible light, on the other hand, are generally considered safe and are essential for life on Earth. It's important to understand the potential hazards of different types of electromagnetic radiation and to take appropriate precautions to protect oneself from overexposure. Radiation has the ability to penetrate matter as well as being invisible helps explain why ionizing radiation is a hazard. Alpha particles are relatively large and heavy, consisting of 2 protons and 2 neutrons, and have a positive charge. They can be stopped by a sheet of paper or a few centimeters of air, but can penetrate the outer layer of human skin, causing damage to living tissue. Beta particles are fast-moving electrons or positrons and have a negative charge. They can penetrate further than alpha particles, traveling several meters through air and a few millimeters through aluminum. They can be stopped by several millimeters of plastic or a few centimeters of water. Gamma rays are electromagnetic waves with no mass or charge and can travel long distances through air and other materials. They can penetrate several centimeters of lead or several meters of concrete, making them very difficult to shield against. Neutron radiation consists of particles called neutrons, which have no charge but have mass. They can interact with the nuclei of other atoms, causing further radiation to be produced. Neutrons can penetrate several centimeters of water or a few centimeters of lead, making them difficult to shield against. In general, the ability of radiation to penetrate matter depends on its energy level and the density of the material it is passing through. More dense materials like lead or concrete are more effective at shielding against radiation than less dense materials like air or water. Alpha particles can be stopped by a sheet of paper or a few centimeters of air, but can penetrate the outer layer of human skin. Therefore, alpha particles cannot penetrate through a cup of water or concrete, but can penetrate through a thin material like a paper or a hand. Beta particles can travel several meters through air and a few millimeters through aluminum. They can be stopped by several millimeters of plastic or a few centimeters of water. Beta particles can penetrate through a paper and a hand, but not through a cup of water or concrete. Gamma rays can travel long distances through air and other materials. They can penetrate several centimeters of lead or several meters of concrete. Gamma rays can penetrate through paper, a hand, a cup of water and concrete. Neutron radiation can penetrate several centimeters of water or a few centimeters of lead. Therefore, neutron radiation can penetrate through a cup of water and concrete, but not through a hand or a paper.